So I'll just get right into who I am and what our company does and how we relate to the marine industry. So the slide you're looking at is an aerial view of Hartley Bay. We think we're going to get into the battery space, and this would be one of the 350 odd communities that are running on diesel in Canada. So this is something new for us. We started this about a year ago through a supply chain resiliency grant. So I don't know what's happening with the slides, but maybe we could go to slide number 2. Yeah, so we're well established. I know a few of you from the past 20 years that we've been involved in the manufacturing space in Victoria. We are expanding our space always, and so now we pretty much are taking up the whole building that we're in. That's about 6,000 square feet on the plate. Key suppliers to the defense industry. As it relates to marine, we're looking at Babcock Canada, Lockheed Martin, Thales, quite a few of the people that are involved with the submarine program. We're working right now with IMP from Nova Scotia on putting the communications control room racking together, so that's all the communications gear that go into the submarine. So next slide, please. All right. So during the pandemic, we pivoted a little bit. We wanted to get involved with the fight against COVID, and this is an example of something we did with Vancouver Coastal Health. As you know, there was a shortage of masks at the beginning. We even worked on a mask decontamination oven to recycle N95s because they were really in short supply. But once that got taken up, then we were getting masks from all over the world, and they needed to be tested because some of them just don't meet spec. So that's just an example of our capability is very flexible, and we were able to turn this around in several weeks, and it's still being used today by Vancouver Coastal Health. This is part of an ocean supercluster project we did with BMT. The unit you're looking at switches 600 amps at about 400 volts, and it's a micro integration unit. So this is ocean supercluster project putting renewables near the ocean. Very interesting project. This was our part, was just the assembly of that micro integration unit. We're hoping that we can target the 300 odd communities across Canada with this solution. The solution is really good because it uses, I won't say AI, but very smart algorithms to decide what power source to use to minimize the use of diesel.
So Ray, what kind of renewables would plug into this unit?
Good question. So this is in Nova Scotia right now. So it's underwater turbines, wind, everything that you can think of that can be plugged into this is available in Nova Scotia right now.
Cool.
So I think they're just BMT is just starting the testing on that unit at this time. So there's also diesel, which you have to have because sometimes not everything lines up and you need some backup, and then battery. And this time the battery is from Europe, but we're hoping to supply the battery for the next project and the 300 odd more that come along after that. So this is a very interesting project that we did with the Supply Chain Resiliency Grant by the province of BC. So what we did was we bought a robo-drill, which is a very robust mill drill machine, and we applied for a grant to automate that. So there's I think the next slide shows a little video of it actually operating.
Cool. I'm going to press go here.
Yeah. So this was very cool because we we wanted to do this automation, but getting the extra $250,000 on a $700,000 project was really made it so we could do it right. And so we worked with Elliott Matsura in Ontario and a company of their partner company in Australia, and we came up with this solution. And then we got so interested in it, we actually designed some of our own automation components to this.
Wow.
That was adding the CMM. So you'll see a little bit later, we'll ask the robot to give us a part, it'll transfer it to the CMM. And that was our own initiative. We did that outside the program. So there it is, showing what goes on there. So that just makes it safe, so we don't have to interrupt the process. We can take the part out of the mix without having any danger to operators. So we're going further on that. We're just adding induction heating process to this because the robot has about a minute in this particular job where it's idle. So we are going to build in induction heat treatment as part of the process, and that'll take up its whole minute of spare time. So then we say we maximize that automation. The nice thing about this machine is we use it all day as a normal CNC machine, and when we go home, it goes to work by itself. And typically, it'll run 8 to 16 hours while we're away.
Wow. So do you have like an estimate on like what factor it's improved productivity? I guess it really depends on the job, but
yeah, it does. We're making consumables for Nicholson Manufacturing, so it's going to be continuous. And the value add that we did was that we kind of combined all the activities to do with that. So we buy the material, get it cut, we do our machining part to it, we get it painted, and we deliver it to the customer. And we do the induction heat treatment outside right now, but we're going to bring that in-house just because it's way more efficient. So I think companies like that because they used to manage every part of that supply chain. So for something that's happening over and over again, we actually stock like a month's supply. So now they can get instant order fills from us.
wow,
And
nice.
what do we get in return is continuous work, right? So we really like that. It kind of puts pays the rent.
Mm-hmm.
Yeah.
I'm trying to go to the next slide here.
Yeah, it'll be a little laggy. I think it's because of the video, but we get to see Tom Cruise.
Yeah.
I don't know if you guys have seen it, but that movie was pretty amazing.
I did see it. It is very good.
Yeah.
Highly, highly recommended to action flicks or airplanes or both.
Yeah, Tom Cruise knocked it out of the park. So this is something a little bit different. We started this roughly 3 years ago. We're in an international consortium with the Eureka Group in Europe. Our part is a tool sense is what it's called. So what you're looking at there are 3D printed tools. They're 3D printed in steel. And they have all kinds of electronics embedded in them. So the tool on the left is a rotary tool. It has 6 inserts, and each insert has a force sensor behind it. Also has a temperature sensor on the anvil, just under the insert, and an accelerometer. So our part is vibration detection and then fusion of all the signals. And then what you see on the side is a little black cover. One side is a battery and the other side is a Bluetooth module to bring that signal out because the tool might be spinning at 10,000 RPM. The simpler version is the turning tool. So it doesn't really have to have Bluetooth. You could probably wire it, but it's just nice not to have to deal with the things that can happen with wires in a machining environment. Mm-hmm. So we have multi-year commitments with UVic with this. So we work with Dr. Keyvan Ahmadi on this side of it, and then we also work with Zoom and Dong for his battery testing, which you'll hear about a little bit further.
So Ray, bear with me. The application for this would be to increase tool, like reduce tool breakage and maybe
Yeah.
reduce chatter.
Yes. So this is primarily for aerospace, where you're working on very high value components, say a wing spar for an aircraft. If a tool breaks, it could destroy the part. So what this effort is looking at is to be able to detect that something's starting to go sideways and stop before there was any damage. So, yeah, and then about a year ago, we started looking at this idea of there's so much going on with batteries that we applied for a grant from BC. And they gave us $200,000 to kind of figure out where we could fit in the marketplace. And so we think where we're headed is energy storage systems between 0.5 megawatt and 5 megawatts using repurposed EV batteries. So there's a huge amount of these batteries that are going to come into the marketplace, and right now they only have a place to go is recycling. And recycling for these types of batteries is not very mature. So we think we can stall that off for 10, 15 years by just, the power density of an energy storage system is way different than a vehicle moving down the road. So we don't worry too much about weight and volume if it's going to be part of a community trying to store energy for later use or for peak shaving. So this is what we did with the BC government is we worked with CanEV, so Canadian Electric Vehicles is up around Nanaimo, Parksville, sorry, and they wanted to make a medium-duty, roadworthy truck. So right now they make airport vehicles and vehicles that are not licensed or low-speed vehicles. So we went through with them. We hired Zoom and Dong's battery testing lab. So between the three groups, we were able to design a battery pack that could be up to 100 kilowatt hour capacity, which is pretty substantial, but needed for, if you're going to have a medium duty truck going down the highway, it's going to need a fair amount of power to get there, and it needs range. So that was very successful. We didn't get to the point of building the battery because of supply chain issues. So this was, I believe the batteries are here now, but we finished that project 6 months ago. So all the designs are in place, and they'll be assembling that. CanEV is still working with UVic on this, but then we've kind of done our part with that project. Yeah, so this is what's happening. If you just pick on the Nissan Leaf, you could see that there's going to be more and more of these vehicles that are going to age out. So we look at about 8 years as the limit for most EV batteries, where they start to be below 70% capacity. So if you have, a Nissan Leaf from 2017, it has about 160 kilometer range when it's new. The one we have has about 125 right now. And so at some point, depending on how you use it, you're going to want to opt for a new vehicle. Or what's happening with these is there's companies that are developing packs that will go up to, from what we have in our car, 30 kilowatt hour, you can get a 60 kilowatt hour battery. So this is going to be good news for us if we're going to do energy storage systems, because the batteries will be cycling out quicker if there's replacements that reduce things like range anxiety. I don't know how many of you have electric cars, but that's a concern. If you've got something that's got less than 200 kilometers, for most people, you're plugging in a lot. And so So that's where we think our supply chain, and that's just one manufacturer of electric vehicles. There's many and many more coming. Battery technology is getting better and better. So I think most people would want to have something that would give them, like we have a Tesla, we have a 500-kilometer range. That's a nice sweet spot where you feel like you don't need to be looking at the gas gauge all the time. Yep. So this is our end goal right now, is to do this kind of platform that's scalable from about half a megawatt to 5 megawatts. We're going to target 350 odd communities in Canada first, and starting with hopefully Indigenous communities, that because they're very motivated to get off diesel. If you look at Hartley Bay, they're burning about $800,000 a year in diesel, and they just don't want to be doing it. So we'll see how that goes. Yeah, so this was how we ramped up. We just started building our own battery storage units, and so we went from small to big. Big being, 10 kilowatt hour, good enough for test bench work. I don't know if any of you have been to our engineering showcases in Victoria, but we powered that pretty much that whole event with the Prototype C 10 kilowatt hour pack. It was a breeze. It went really well. Yeah, so that gave us the background and the way of knowing, what direction we should pick to go forward with our business. So that was our team. Dr. Dong's group was very instrumental in getting us the core competency we need. So now we're going forward and we're applying for a sustainable technology development grant to turn this into a business.
Cool.
Perfect. So this is something I alluded to a little bit earlier with the micro-integration project. We did that with BMT. Everything's on track and slowed down because of the pandemic, but they're just going to be starting to test these multiple inputs and battery and diesel systems in Nova Scotia. Yeah, so just reiterating the point, we're really looking at second life EV batteries to do fairly good size communities, like between 100 and 300 people is where we think our sweet spot is, because companies like Schneider Electric and guys like that are looking for the bigger projects. They're not looking for super small, being 5 megawatts or less. So why do we want to do it? Well, it's pretty easy to see. Reduce air pollution. It's there's no mature way of dealing with EV batteries now that recaptures everything. So it's pretty wasteful, and I think that technology will get developed, but it'll be like anything else. It'll be volume driven, and there's not enough volume right now to develop specifically plants that. This process can be done in the lab, but to do it on a commercial level needs constant input. So we don't have that yet. So we're going to help the recycling industry by holding on to those batteries and squeezing every last amp hour out of them. And yeah, so that's basically what's going on with that side of the project. Next slide, I'll show something a little bit different. So this is something we're working on with Greg Marshall, Neighbor Architects. It's not a done deal. We're in the proposal stage, but they actually are going to build their own catamaran, a 40-foot catamaran, and they want it to be battery powered. So this would be about a half megawatt battery pack. That's our part of the project. They'll be designing. They're just in the beginning phases of designing the catamaran now. So I think we have about 2 years to complete it. And so like I say, it's not a done deal, but I really hope we get going with this because it's an exciting project, and I think it's the future of the boating industry.
Yeah, as a sailboat owner, I would like nothing better than to have an electric battery and motor in mind. So it sounds amazing. I mean, there's so much volume in a sailboat or in a boat generally. So
Yeah. Well, it's weight, right? So that's the big thing. Is what I hear from naval architects is, the cost of a kilogram is about $300. So they're going to try and reduce weight as much as possible.
right.
So yeah, we saw it today at the ABCMI event. I won't say the name of the company, but they're building an electric outboard, and they were demonstrating it in a video, and it didn't look like what you see on the Greg Marshall. It wasn't getting up on the step. You know what I mean? Like there's
Okay.
a lot of weight and batteries there.
Right. It wasn't coming up on plane.
No, it was just kind of plowing. So, I think that's
What?
the challenge, right?
Yeah. I mean, you don't have to worry about that with sailboats, thankfully. So
Yeah, that's true. And slower speeds, you can do pretty well with batteries. So I think as long as you're not going to be towing water skiers or something like that,
mm-hmm.
okay. That's a good place to start because batteries are getting better. Energy density is getting higher and higher, even in lithium iron batteries. And I really like those because they're safer, right? Lithium ion batteries, like in Teslas, catch fire and propagate. Lithium iron tends to be safer and they don't propagate, and they live a long time. Like I'm just starting to distribute batteries for a company called Atlas ESS. They're a U.S. company, and we're going to distribute them here. And the warranty is 15 years on those batteries, so that's pretty good.
Wow.
Yeah. So this last slide is a little bit of a pitch. We hold an engineering competition every year. Well, we call it a showcase now because there's such a diversity in skills and ages and experience that we get everything from the Fix-It robot grade school kids to all the teams at UVic that we sponsor. And some of you know about it already. So I think that's we really promote local manufacturing, and we were trying to get people excited about manufacturing industry and the stability of that. Like if you have a manufacturing company, there's a lot of infrastructure, so it's going to stay around a long time, and it's getting more and more exciting to see what happens there. So this satellite is going into space before the end of the year.
Wow.
Yeah, the teams that we work with are very dedicated, and wow, I'm impressed. They have a underwater submarine that's driven by a person, like they pedal it. There's
I've
robotics.
heard of this.
Yeah, there's so much diversity in what they do, and they win competitions, do really well. Formula SAE, they have an electric car now and a hybrid. So very cool. The guys at work really love working on this stuff because it's pushing limits, and it's really fun to see. So I invite you to come out to the show and be on September 29th. Got pushed off because we're negotiating for the car shop, which is by the Roundhouse, by the Bayview development. And so we got shifted because everything's coming back now, right? So many people want these kind of venues. So September 29th, put it on your calendar.
It's in my calendar.
Yeah.
I think I just
I have to say, as a student team, that there's a lot of the UVic engineering teams that wouldn't be able to do anything without Rainhouse's support. They're huge, and what they do is really critical for a lot of these engineering teams. Because if you don't have a product, you can't do anything with it.
Yeah, Yeah, our commitment's a little different. We give out about 240 hours of our time per year, and then we let the teams manage that. So I think it's good for engineers to learn how to manage time and prioritize, because what was happening is they'd all come to us at once, and then we'd be flooded with non-revenue work, and so this levels it out a little bit, and it's super fun. We really enjoy doing it, and I don't see us ever stopping that. It pays back. Some of my customers, maybe somebody right here, went through that and remembered Rainhouse when they went to work, when they were in a position to make decisions on where work goes. So it pays back. It's just a long cycle. So I invite you to ask me anything you want about what's going on.
I had a question for you.
Mm-hmm.
The batteries that you're developing for this yacht, they're going to have to be a lot more energy dense than the ESS systems that you're working on. I imagine you have quite a bit of experience just in batteries in general, but how does the two projects kind of tie into each other?
Yeah, you're kind of breaking up a little bit, but I think you're asking me about is there different battery types for energy storage systems and something that would be on ship? Yeah. Yeah, so obviously the go-to is lithium ion because they're the lightest, most energy dense battery. But they're also dangerous bombs that need a lot of auxiliary systems. You have to cool them. You have to really do a lot of things to make them safe. So we haven't totally made our decision yet, but we're leaning towards lithium iron because the power density of those batteries is going up quite well, and they're safer. So you can drive a spike through one, and it's not going to catch fire. So it's not to say you can't, because I was just at NRC's lab in Ottawa, and they were showing me lithium iron batteries that they flamed up, but they were using nichrome wire up against the battery, heating it up to a very high temperature to make it burn. They love burning things there. They showed us videos of a whole electric car they burnt. They burnt full battery packs. And they love to destroy things just to see what happens. So I'd love to have their job. It's great.
Sounds like an expensive version of Will It Blend, almost.
Yeah, very expensive.
I've got a question for you, Ray. So this is a really interesting concept where you're using, I like the way you put it in one of your slides, second life batteries, right? And it's a really puts yourself in a good position because the resource is simply growing, and there's going to be lots more available resource. But one question I had was, how do you, I mean, there's not exactly a supply chain infrastructure set up for that, right? So,
yeah.
What's your sort of near-term plan for that? Is that just literally, there's a Nissan dealership in town, and like, what are you guys doing with those batteries? And,
Yeah, we were able to buy, we bought a few Nissan Leaf batteries and Tesla battery fairly easily. But you're absolutely right. Supply chain has to be nailed down. So we're talking to car makers about this, expressing interest in taking batteries. So it means you have to be able to take them as they come. So it's it's a little bit of a risk because you have to have it's that catch-22. But going to auto wreckers is probably not the best way. We know some enthusiasts in the Victoria area that love doing this, so they've kind of got an ad hoc supply chain, and then we're backing it up with other batteries. Like we're working with Atlas ESS to have a supply of batteries that are new, because not every customer is going to want that, and we could actually have hybrid systems where we'd have both, and I think that's a possibility. Is we would have kind of a sliding wedge. At the beginning there would be more new batteries, and then as we get more supply of repurposed batteries, we would just shift with the next installation to have something more reflective of that. And the nice thing about it is we have a product that's going to get better just because the batteries that we get in the future are going to be better than the ones we use. So it's I think a beautiful business model for growing something that really helps the environment. People feel good about it because it's, you don't have to mine anything. You just mine it from the cars that can't use that anymore.
Yeah, brilliant. So for that matter, I mean, I know that's putting the cart before the horse a little bit because it's like, let's solve the problem we have in front of us today. But, you look at these energy storage units that might be there it's for a community. It's going to be there for umpteen, however long you want, right?
Yeah.
Are you thinking about like, well, we'll have this battery pack we could potentially swap out and swap in again, 10 years later when there's as much as you can. I mean, you don't know what the next Nissan Leaf battery technology might look like, but you get something, right?
Yeah, I think you just hit the nail right on the head. So our model will be to have multiple EV batteries in a rack system, hot swappable, so we can drain as much out of the battery as possible before we pull it out. So we're not really interested in opening up battery packs for all kinds of reasons. We've done it. We know what that's like. And I think we could do it to fix a problem. Say there's one bad module in a battery, then we could fix that and put it back in service. But the newer batteries, like if we took apart a Model 3 Tesla battery from 2019 car, it's got 4 modules and they weigh like 250 pounds each and they're glued together. So you're not going to be able to service that very efficiently. If you look at the 2011 Nissan Leaf, they have 48 modules. They weigh like, 8 pounds each. They're easy to deal with.
Is this all based off the Panasonic 18650 cell, that little sort of AA size cell?
Well, the Teslas were 18650s. Now they're 21700s, so a little fatter battery. Nissan Leafs use pouch batteries, so they're like a small iPad size battery, and they stick 4 of them together, 2 in series, 2 in parallel, put it in the case, and they have 48 of them, a 400 volt battery pack. So interesting technology. Everybody has a different idea. Their idea was to use pouch. Tesla likes cylindrical batteries, but I see now in China they're starting to use prismatics. So that looks like a battery in your emergency light system, UPS or something like that. So, and why is that? Is because they're simple things to put together. I think way better than if you look at a Tesla battery, it has like 7,000-8,000 cells in it, and they're all tab welded. So each battery has its own fuse. So it's a pretty complicated. You need some pretty sophisticated infrastructure to make that work, and it works for them because it's basically something that will just get used, and they have no ideas about servicing that. Right? They would just replace the whole thing.
You mentioned, I think, early on that battery recycling for these sorts of batteries is immature, I think, as what you said. Does that just mean that they can't do it for a lot of these batteries, or they just can't do it very efficiently? It's very costly to do? Or?
Yeah, I think it's the infrastructure required to, I think now recyclers can't really get the lithium out of lithium batteries because it's it's not that huge a component. It's hard to separate. So I think what's going to make that happen is volume. Once you've got, it's just like a lot of processes like anodizing, for example. You don't want to be doing that once a week. It has to be a continuous flow. You need to titrate chemistry to make sure everything's going to work. So I think that's the way it's going to work with battery recycling. It'll just have to be enough to have a steady stream of these things going through the process.
Mm. Interesting.
And it's dirty, right? It's a very dirty process.
Mm-hmm. Cool.
Do you the energy storage project? Do you see sort of Rainhouse eventually producing those, or do you think you'd spin something out to just focus on that?
Sorry, I didn't catch the first part of what you said.
Would you see Rainhouse actually producing those energy storage systems, like once you get up to sort of serial production, or is it something you'd probably spin out or license maybe?
Yeah, it's really hard to say. We're looking at signing an agreement with BMT now to produce the micro integration unit I showed at the beginning. So we would be manufacturing those. I think for all kinds of reasons, if we're successful with the battery side, we'll spin off another company. And then who knows, like anything's for sale. So that could happen. Or we just grow it ourselves, right?
Mm-hmm. Very cool.
Yeah.
Any more questions, guys? No? Ray is on Slack now. So if you guys think of anything, because there's lots of cool stuff in that presentation, you can just hit him up on Slack as well.
Sure. Yeah.
But otherwise, maybe we will close it down there.
Okay. That's awesome. I'm going to race to the ferry now, and hopefully I'll get the 7 o'clock to go home.
Awesome.
Yes,
Right.
thank you so much, Ray, for making time. Really appreciated the presentation. And really cool to see some innovations and new things that you're working on. And yeah, it seems like you're really well positioned. I love the marine theme as well. I'm aware of Greg Marshall, Naval Architects as well. So it's just really cool to see those kinds of local innovations together and that sort of thing also.
Absolutely. Okay, guys. Well, thanks so much for listening to my presentation. If you're in the Victoria area, obviously, you should drop by and see some of the things we're doing. I can't be more proud of what we've built there over the last 20 years, and I think it's just going to be pretty awesome going forward. I should be retired now, but I just keep going to work. I can't stop.
Thanks, Ray. It's been great seeing the company progress over the years and some really amazing projects you guys are working on. It's a pleasure. Thanks for sharing.
Thank you.
By the way, if you guys know of anybody who's looking for a marketing job, we just lost our marketing person, so you know what it's like right now with people. It's super hard to get. So we're looking for a good marketing person to take over for our last effort. She's done a great job. How many of you have seen us on social media?
I think
1, 2, 3. Okay, so a few. All right. We're reaching, looks like maybe 30%.
You got a good Instagram. You got a good Instagram.
There you go.
More of
All
us
right.
will be looking now. Good presentation, much appreciated.
Okay.
Nice to know what's going on in Victoria, and nice to see the innovations. So
Yeah.
good on you.
Yeah. All right. You take care, and thanks so much.
Thank you.
Thanks, Barry.
Indeed. Thanks very much. Take care, everyone.
Cheers. Bye-bye.